And now what I'd like to do next before we move on to working on the bind solution is just to clean up this code a little bit. So what I did in this code over here is I started with int values as I show here and up here. And usually I do that when the problem is difficult and I'm like, well, I really just can't even think about generics right now. Let me just use an int or a string to solve these problems. But to make our wrapper class more useful so that it can wrap anything, what I want to do now is go ahead and make this generic. So a simple way we can do that, as I note right here, is we can change all the int references to the generic type A. So I'll just do that right there, and I'll just do this manually, like that. All right, I think I got all of those. And now the only thing we need to add to that is that the map and flatMap signatures actually can transform the A to the generic type B. So what I would need to do there is change that to a B right there, and that to a B, and that to a B right there. And then the part I usually forget, again, because I don't use an IDE, so we have to declare B right there and B right there. And I'll save that and see if I made any mistakes. And I did make a mistake right there. So that one's going to be an A. And when I scroll down here, you saw that it is now working properly. So again, when generics are too hard to think about, I usually just use an int or something like that there. And now I could do something like that with a string. And just to keep it simple, let's get rid of one of those. And that one as well. And now we'll do something like A, and how about BBB right there. And the string works here because you can apply this algorithm right there to a string, just like you can apply it to an int. So I just wanted to show that this is now working generically. It works for the int type, and it also now works for the string type. And indeed, it should work for any type where A plus B matches. So if you want to go crazy, we can say, how about a double? And then we'll say, well, how about 1.1 right there? And then 2.2, and save that. And whoo, we get to see an interesting thing about the JVM right there. How about that? I noted this in the Scala cookbook. Sometimes 1.1 plus 2.2 isn't exactly 3.3. So that is a known issue right there. And on a totally unrelated note, when you want to get away from that problem right there, what you do is you use big decimal up here instead of double. And that will get you the solution that you would like. Now here we're at an interesting point in this book and this video series. In the next lesson, which is 68 in the book Functional Programming Simplified, remember that this was written for Scala 2. So we had to do some things back then to say that, well, when I don't want to write new wrapper and I just want to write wrapper, there are some things that we have to do. And I talk about that in this chapter right here. And the solution is to create an apply method in a companion object. And then I show how to change the code here. So if you have a copy of the book, feel free to look at it. Or if you'd like, I'll just scroll another page like that. And you can read this page. And then you can read this page. And this page. And this one too. And again, my whole reason for writing that was I just wanted to be able to say wrapper here instead of new wrapper in Scala 2. And this approach was kind of cool in Scala 2. Let me go back to the solution here. So now in Scala 2, the code looks like this. What you do is you make the constructor for the class private. Everything else looks the same. You still get that value and everything else. So the only thing you do here is you make the constructor private. And then you create a companion object for your class, and you create this apply function right here. And this one is actually really interesting from a theoretical standpoint. So keep that in mind, and let's go to that next page. On this page, I note that the reason I wrote that apply method in the companion object, rather than switching over to a case class in Scala 2, is this technical one. And that is because functional programmers like to say that apply method like that lifts an ordinary value into our wrapper. When you think about it, an integer on its own looks like that. But when you use apply to lift an int into the wrapper like this, you can think about a box analogy. And now wrapper is a box and it happens to contain 100. And the way we got the 100 into that box was with that apply method. And again, we like to say that apply lifts an ordinary value. So int is considered an ordinary value, and it lifts that into our wrapper. And so now what we have here is a wrapped 100 value, or you can think of it as a 100 inside a wrapper or 100 inside of a box if you prefer. So in terms of key points for these last few videos, on the one hand, the lessons that we've done have been a series of small steps. So in this particular area, we showed how to create a wrapper class. We showed how to write a map method and a flatMap method, how simple they are in this use case, and then how that would work inside of a for expression. And then we created the values to generic values or generic types. So now we can use different types inside of here, anything that supports the a plus b. And then if I go back to the book over here, I also showed how to write an apply method to lift an ordinary value into our wrapper like that. And the reason I keep emphasizing this thing where we just lifted an ordinary value into a wrapper is because you just wrote your first monad. So whether you knew it or not, we just intentionally wrote our first monad in this video course. So technically, a monad in Scala is just a class that implements map and flatMap methods so it can be used in a for expression. And in Scala 2, we would also implement an apply method to lift ordinary values like an int into our monad. Or in this case over here, I'm now lifting a big decimal into our wrapper monad. So again, if you've never written a monad before, congratulations. Pat yourself in the back. If you understand all this code over here, you're doing great. Hope going through this process helps you understand monads and lifting ordinary values into a wrapper or into a monad. What we have to do now is we still want to get that bind function working. So I still have to do whatever I need to do to get something like a bind function working so I can use it in a for expression like this. And for us to do that, we're going to use everything I just showed about map and flatMap and apply to solve our binding problem. And we'll do that starting with the next video.